Hello and welcome to the Terran Space Academy, where we help prepare you for a bright future in the space industry. Please don't forget to like and subscribe, and support us on Patreon if you can. There is a link in the description. We also have merchandise available, and there's a link there for that too. To truly master a science requires a deep understanding of the fundamentals. We now have over 5,000 scholars enrolled. Some of you have been with us from the beginning, and some of you just joined. We appreciate you all and wanted to take this opportunity to say thank you. In honor of this milestone, we wanted to take a look at the most important equations in rocket science and establish some definitions that we will do our best to adhere to so that we can all be on the same page. First, the definitions. A rocket is a cylindrical projectile that can be propelled to a great height or distance by the expulsion of mass by thermal expansion. This is a rocket. This is not. Even though it may have a rocket engine, it's not a cylinder. An ion drive ship is not a rocket. It does not use thermal expansion. It is a spaceship, though. The first 3 stages of the Saturn V were rockets. The capsule itself was a spaceship. All rockets and spaceships created so far use thrust to propel themselves into and through space. Thrust is the force produced by a rocket or other engine, and force equals the mass times the acceleration of a specified amount of matter. This gives us kilogram meters per second squared, or newtons. There are several ways to calculate thrust. For a rocket engine, the mass involved is in the form of propellant. The propellant mass is thrown out of the rocket engine at a fairly constant rate and velocity. To get the force or thrust of our rocket engine, we multiply the mass propellant flow, given in kilograms per second, times the exhaust velocity, in meters per second. If you notice, multiplying these gives us the same units for force as above. To calculate mass fuel flow, you can divide total propellant mass by total burn time. The exhaust velocity is sometimes given, but more commonly, you will be given the specific impulse. Specific impulse is how we measure the efficiency of a rocket engine. If you take the exhaust velocity of your rocket and divide it by the force of gravity on Earth, 9.81 meters per second squared, you will get the specific impulse. This number is reported in seconds. All rocket engines are compared with this number. It can be lower than 100 seconds with a cold gas thruster, or as high as 450 seconds with a hydrogen-fueled rocket engine. A nuclear thermal engine can be as high as 900 seconds, and there are several ion engine designs that can go up to 1,500 seconds. And finally, the Vasmer engine can produce up to 5,000 seconds of efficiency. This also means that if you take the specific impulse and multiply it by 9.81 meters per second squared, you will get the exhaust velocity. The most important equation in rocket science is the rocket equation. This equation was first defined by Konstantin Tsiolkovsky. Tsiolkovsky was a self-taught theoretical rocket scientist. He calculated that the change in a velocity for a rocket of any size will be equal to the exhaust velocity of the propellant times the natural log of the initial mass over the final mass. The natural log is a somewhat complicated mathematical factor. The natural logarithm of x is the power to which the constant e would have to be raised to equal x. E is the constant 2.718, and it goes on, but I leave it there. What you need to remember is, find the exhaust velocity of your engine. Again, this may be given, but if not, and you have the specific impulse, simply multiply the specific impulse by 9.81 meters per second squared to get the exhaust velocity. Find the initial mass of your spaceship. Find out the propellant mass to be burned. Subtract the propellant mass from the total mass to get the final mass. Then go find a cheap calculator. Put everything in and push this button for the natural log function, and get your answer. The answer is in meters per second. This is called your delta V, or change in velocity, and is usually reported in kilometers per second. These concepts are vital to understanding rockets. The first equation answers, how efficient is my rocket engine? The second one answers, where can I go with my spaceship? Since all destinations in space are measured in terms of delta V. Here is a delta V map showing you how to get into orbit, to get into a lunar transfer orbit, to land on the moon, to get into a Mars transfer orbit, and to land on Mars. It shows us how much delta V we will need to get anywhere in the solar system. Review and know these concepts well. Again, we master a subject, not by knowing 1,000 facts of trivia, but by a deep understanding of the fundamentals. For rocket science, calculate and study specific impulse, thrust, and delta V, and the factors used to calculate them, until you have a full understanding. Thanks for listening. Please don't forget to like and subscribe. Lesson 2 will be available soon. Stay safe. At Astra Pro Terra.